Moving on to chapter 2, part 4, we're going to talk about water, which is a really important molecule in the human body. First off, we have this animation link, so be sure to click on this link right here on your slides and watch the animation for water. It's really informative. So water is the most important and also the most abundant inorganic compound in all living systems. Really, all the body's chemical reactions occur in a watery medium. Water has many properties that make it such an important and required compound for life. We've already talked about one of the most important properties of water, and that's its polarity. Remember, that's the uneven sharing of electrons, where the electrons are pulled more towards one atom than the other. And this puts a partial negative charge near the oxygen, as you can see here. And it puts a partial positive charge on the hydrogen. So these electrons that are shared between the oxygen and the hydrogen atoms in water are pulled more towards the oxygen, making it more negative on the oxygen and more positive on the hydrogen side. This property makes water really an excellent solvent for other ionic or polar substances. And this gives water molecules cohesion. Like I said, that's the tendency to stick together. And it also allows water to be really resistant to temperature changes. So here we can see a very simplified version of the structural formula for water. And you can see how it's polarized here. So we're going to have the negative charge on this side and a positive charge on this side. So it's very polarized in the charges. In a solution, a substance called the solvent dissolves another substance called the solute. So usually when we're talking about solvents with water, water is going to be the solvent. And in this case, salt or sodium chloride is going to be our solute. And this is spelled solute. And water is going to be the solvent. So really, water is quite versatile, especially as a solvent for ionized and polar substances. And this is due to the polar covalent bonds and also its bent shape. So like I said in the last slide, because it's bent, you have kind of this side of the molecule is going to be positively charged, and this side of the molecule is going to be negatively charged. So this bent structure really helps with its polarity and helps with its property as a solvent. Solutes that are charged or contain polar covalent bonds, these are hydrophilic. Hydrophilic. Philic means loving, and hydro means water. So ones that are charged, like sodium chloride, sodium has a positive charge, chloride has a negative charge. These are going to be charged ions, and they're going to be hydrophilic because, like water, there is also charged. Remember that like dissolves like, so because they're charged, they will be dissolved also in a charged solution like water. Common examples of hydrophilic solutes are going to be sugar, salt as well. Molecules that contain mainly non-polar covalent bonds, these are going to be hydrophobic. And this means that they fear or they hate water. Hydrophobic, just like phobias. Phobic means fear or hatred of. So these compounds that have non-polar bonds, these are not going to be very water soluble at all. So examples of hydrophobic compounds, these are going to be like fats and oils, that kind of stuff. They don't dissolve in water very well. And we know that when we put like some vegetable oil or canola oil into water, a glass of water, they don't dissolve at all. They stay separate because oil is very hydrophobic. So to understand the dissolving power of water, we're going to look at what happens when a crystal of salt, which is this, the sodium chloride, is placed in water. So the sodium and the chloride will actually separate into their compounds or to their ions, so a sodium ion and a chloride ion, and they'll actually dissolve in water because of the negative and positive attractions. So because sodium is positive, it's going to attract that negative end of the oxygen of water, and because chloride is negative, it's going to attract the positive end of the hydrogen part of the water molecules. So they're going to dissolve, or they're going to have water molecules surround each ion, essentially is what happens when things dissolve. Water is really an ideal medium as well. So here we have a hydrolysis and dehydration synthesis reaction. On the top, so this is a reversible reaction. So here on the top side we have dehydration synthesis. So this is the combination of glucose and fructose into sucrose. So here we have OH2 that is going to be removed as a water molecule, and then we're going to have these bonded together. And then the opposite will occur when we have a hydrolysis reaction. We take sucrose, we add water, and then in the end we get glucose and fructose as two separate compounds. So water is a major component of mucus and other lubricating fluids throughout the body. Lubrication is really especially necessary in the chest, in the pleural and pericardial cavities, as we spoke about earlier, as well as the abdomen, in the peritoneal cavity. And this is where internal organs will touch and slide over each other. So water aids in protecting your organs, because with that amount of friction, if we didn't have any lubricating fluid like water, the friction would do a lot of internal damage to those organs that are rubbing against each other. And that will be the end of part 4.